I'm going to go back over and I'm going to try to do a video of everything here for the finite review. For number 1, it says find the probability that a mouse ends up in a compartment 2 if it started in compartment 1. So to do that, you have to say, well, what happens if I do multiple trials? And so I would take that whole matrix, take it to the 99th power, and then you can look and see what the probability is from compartment 1, if they started in 1 and they went to 2. Now, obviously for the original it's 0.3, but if you take it to the 99th power, you get 0.491, which is the correct answer. For number 2, it says construct a truth table for the compound statement. Number 3 has you do this too, so I'm only going to do one of those. We have P, R, and T. So since I have 3 letters, 3 values, I'm actually going to end up with 8 rows because I take 2 to the 3rd power. 2 being like it's true and false, and then the 3rd power being I have 3 letters. Okay, and then I also have a not R, so I'm going to include that as a column. Hopefully I've got enough lines now. So for P, I would have 4 trues and 4 falses. And then I just alternate, I'll do, for R, I'm going to do 2 trues and then 2 false. And then for T, just true and false. So that should give me all of my options. And then not R would be the opposite. So if it's true, then it's going to be false. And then I'm going to do the first half, which is P and R. I'm going to do a column for the second half, which is not R or T. And then I want an entry for the last column, which is combining those two. So P and R. And not R and T. So P and R, to have an and, they both have to be true. So the first one's going to be true. The second entry is true. The third entry is false because I only have one of each. The fourth is false. And then the remainder will also be false because, again, you had to have 2 truths. For an or, you only have to have one of those true. And we're looking at the not R column and the T column. So for the first entry, that's going to be true because I do have a false, or 1 true there, sorry. The next one I have 2 falses, so that one's false. The third entry is true, 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 false, true, true. And then I'm going to combine my last 2 columns there with an and, so I'm looking for 2 trues to do P and R, and not P or T, or not R or T. I need 2 trues. True. Looks like the first one is the only time that happens, so the remainder of the values will be false. So that's a truth table for number 2. Again, I'm not going to do number 3. Number 4, it says decide on the payoff in this game when the specified strategy is used. So it says basically row 1 then column 2. What's happening there? So I go to row 1, column 2, and I get -2. And that means that when that's negative, A is losing $2. So the answer is that A pays $2 to B. Number 5. Sam plays tennis or George is not a man. If George is not a man, then Betsy does not win the award. Betsy wins the award, therefore Sam does not play tennis. So I've got Sam plays tennis. That's a positive, so I'm going to say S is Sam plays tennis. So not S would be if Sam does not play. I'm going to make G, it says George is not a man, so I'm going to make George is a man. And then that would, of course, mean not G is George is not a man. B for Betsy. Betsy does not win the award, so positive there would be that Betsy wins the award. And Sam does not play tennis. So our different statements are that Sam plays tennis, so that's an S, or George is not a man, so not G. If George is not a man, so not G, then Betsy does not win, so not B. And then we have just a statement that says Betsy wins, so B. And then we want to solve and say, therefore Sam does not win the tennis, does not play tennis. So therefore not S. So we have to have that solution. What we did is we looked at our 3 statements and then we want to end with a not S. So we put together some values, and the first one was we combined 2 and 3. So we have not G, then not B, and B. And that was number 1. And from that, we found and I want to say that's the loss of syllogism. I think maybe I have the wrong one. I think maybe I have the wrong one on that one. This is G. So 4. So we had several different statements that said whether something was valid or invalid. So you can see that I don't have a statement 4 in my original statements. That's because I have a new one. And then we're going to combine 4 with 1. And actually I had to reverse number 1. So I wrote it as not G or S, then G. And what I should get at the end is S. Well, that does not equal not S, which is what I was looking for. So these two really needed to match, and they didn't. So we say that this is invalid. Number 6, you just had to do a permutation. You can do that one on your calculator. Number 7, that was one where we had to do an equilibrium vector. So you have to set this up. We have 2 rows and 2 columns. So that means we have vector 1, vector 2 times that matrix. And then that is going to also equal vector 1, vector 2. What we want to do is make some linear equations out of these. So I'm going to multiply the first matrix times the second matrix, And you should get 0.41 v sub 1 plus 0.39 v sub 2 equals v sub 1. And then we're going to multiply this by the second column, and that's going to give me 0.59 v sub 1 plus 0.61 v sub 2 equals v sub 2. I also know that when I have a equilibrium vector, that the entries have to equal 1. So that means that v sub 1 plus v sub 2 equals 1. I want to take each of these and set them equal to 0. So bring everything to one side. When I do that, my first equation is going to look like negative 0.59 v sub 1, because I'm going to subtract 1 v sub 1, plus 0.39 v sub 2 equals 0. So that's my first simplified equation. And then the second one is going to be negative 0.59, or excuse me, positive 0.59 v sub 1 minus 0.39 v sub 2 equals 0. You can see that the terms are almost the same except for the positive and negative. And if you multiplied through by a negative on both sides of the equation, they really would be the same. So technically, I only need one of those. I'm going to take that first one, and then I'm going to also use v sub 1 plus v sub 2 equals 1. What I would do with all of this is I would take these two equations, again, because the first and second one are really the same. I only need to use one of those. And I would let v sub 1 equal an x and v sub 2 equal a y. And I would just put those in my graphing calculator, probably Desmos, look for their intersection, and that's going to tell me what x and y would be, which is the same as my vector, v1, v2. And we would find out that x equals 0.398 and y equals 0.602. And so those would also be the entries in my equilibrium vector. For number 8, that was our easy question. We just need the median, which is the middle number. Number 9, we want to find the probability of the indicated result. And it says use the normal curve approximation to binomial distribution. I actually did this one several times, and I came up with a little bit different answer. It's closer to the one that the answer key gave. Actually, I would take either one because it's a different form. So you could use just binomial probability. To use binomial probability, it says a die is rolled 72 times and 10 threes come up. So for you want the probability of 10 threes. So to do that, you're going to take the combination of, well, you had 72 trials, and you want 10 of those to be threes, times the probability of getting a 3. Well, if you have 6, or 6 values on a die, the probability of getting a 3 is 1/6. So the probability of it being a 3 is 1/6 for each roll. We wanted 10 of those. The next one is the probability of it not being a 3, which is the remainder, which is 5/6. And so we would have 62 of those, and then you would solve that. And we actually got, I got 0.10929. The other way to do this is using your graphing calculator, and you have n is the number of trials, which is 72. The probability of getting a 3 is 1/6. And so we're going to find the mean of that data, which is n times p, so 72 times 1/6, which is 12. And then the standard deviation, which is the square root of n times p times 1 minus p. And so that's really just the square root of 12 times 5/6. So we get the square root of 10, which is approximately 3.162. To use the normal curve approximation to binomial distribution, what you do is you say, okay, well, I want 10 outcomes. And we're going to look at a range of what that looks like. So 10 is actually between 9.5 and 10.5. So we're giving it a range. And what we want to do is find the z-score. The z-score is x minus the mean over the standard deviation. So we're going to do, we do one for 9.5. So that's 9.5 minus 12 over the standard deviation of 3.162. And I got negative 0.791 and negative 0.47. Well, 0.791 for 9.5. And then we do z sub 2. The other z-score is for the 10.5. So you take 10.5 minus 12 over 3.162. And you get that z-score, which is negative 0.474. Now what do I do with all that good stuff? I'm going to use my handy dandy calculator to do the normal CDF. And that's in your distribution menu. And you just take your z-scores. You take negative 0.791, comma negative 0.474, and I got approximately 0.103, which is almost the 104 that we got in the answer key. For number 10, it says a family has 5 children. The probability of having a girl is 1/2. What's the probability of having at least 3 boys? So when I have at least 3 boys, that means what's the probability of having 3 boys? Or maybe I have 4, or maybe I have 5, and I'm going to do the binomial probability for each one of those. So the probability of 3 is the combination of, well, I've got 5 kids, 3 of them are going to be boys. The probability of having a boy is 1/2. Since the probability of having a girl is 1/2, boys also has to be 1/2. going to have 3 boys, which means that the probability of having a girl is 1/2, and I'm only going to have 2 of those. So I would find that result. Then I would do for 4. That's a combination of 5 choose 4, and then I have 1/2. I want 4 boys and 1 girl. And I'm going to get an entry for that. And then the probability of 5 would be the combination of 5 choose 5 with 1/2 to the 5th power this time. And for the girls, I don't have any girls, so I got 1/2 to the 0 power. And I would add all of those together, and I get approximately 0.5. So that's the probability of at least 3 boys. Number 11, a coin is biased to show 37% heads and 63% tails. The coin is tossed twice. What's the probability that the coin turns up heads once and tails once? So it's really binomial probability, but it's not the usual because in this case it's weighted. So the probability of getting heads is at 1/2, it's 0.37. And the probability of tails is 0.63. But it's still binomial probability. There's only 2 choices, heads or tails. So we're going to toss 2 coins, and you have to pick a focus. You're either going to focus on probability of getting heads or tails when it's both. So I'm going to say, well, what's the probability of getting 1 head if I toss the coin twice? Okay, which in turn would mean I got 1 tail. So combination of 2 choose 1. The probability of getting a heads is at 1/2, it's 0.37. And I want 1 of those. And then the probability of getting a tails is 0.63, and I want 1 of those. And you'll work that out. And I get 0.4662. Number 12, this one, I'm not going to do this one again. It's just like number 10. I will kind of give you a hint. We want at least 4 girls. So we want the probability of 4 plus the probability of 5. Number 13 just wants you to find the standard deviation. If you enter all of this data in list 1, any list really, but list 1, 2, 3, whatever, okay? And then you can go to math, the math menu. I'm pretty sure, hang on, maybe it's the list menu. It is, I'm sorry. So if I go to second stat, which is the list menu, and I go to math, I can go down to standard deviation. So I'm going to do second stat, math, 7, and that's going to be the standard deviation. And then I put list 1 in, and it's going to give me the standard deviation for that set of data. We've done truth tables. Again, it wants to know, it says find the truth value of the statement. For the truth value problems, the only time you're going to get, when you've got an if then, when you have a P then Q, is if it's true and then false, then the whole thing is false. Otherwise, it's going to be true. And that's the case for 14 and 15. Number 16, given a group of students, Alan, Brennan, Chad, Dorothy, and Eric, count the different ways of choosing the following officers. Our representatives assume that no one holds more than one office. So we want a president, a secretary, and the treasurer. If the president says must be a woman, and the other 2 must be men. So I'm going to have 1 woman and 2 men. So I've got the president, the secretary, and the treasurer. And it wants to know how many different ways. So it's not a probability, it's just a number. I have Brenda and Dorothy are my women. So I have 2 choices for the president. For the secretary, there are 3 men. So one of those has to be the secretary. So I have a choice from 3. And then once I put somebody in for secretary, I only have 2 choices. So I'm just going to multiply those out, and I get 12. Number 17, it says if the given diagram can transition. So we want to know if it's a transition diagram. Basically, I'm going to take those values and I'm going to put in a transition matrix. It's easier for me to do that. And make sure that all of the rows add up to 1. If they don't add up to 1, then it's not a transition matrix, so it's not a transition diagram. Number 18. Says that a certain college, 33% of the physics majors belong to an ethnic minority. Find the probability of the event for a random sample of 10 students who are physics majors. So this is another example of binomial probability because we have 2 possibilities. You're either a physics major or you're not a physics major. And it says 7 or more belong to the ethnic group. So 33% belong to the ethnic group. So that's ethnic is 0.33, and then non-ethnic is 0.67. So those are our probabilities. And I want the probability of 7 or more. Well, I have 10 students altogether, so I have to have the probability of 7 plus having the probability of 8 plus the probability of 9 and then plus the probability of 10. I'll just do one of these. If I want the probability of 7, that's 10 students. I want 7 of those to be in the ethnic group. The probability of an ethnic student is 0.33. I want 7 of those. If I have 7 ethnic students, then I have 3 non-ethnic. Okay, so obviously I'm going to get a value for that. I'm going to do that for each one, 8, 9, and 10 as well. And then when you add them together, you should get a probability of 0.0185. 19, just like the median problem, was pretty easy, so is 20. I think that's fairly self-explanatory. 21, you had to decide on the truth value for those. Again, we talked about that. Let's jump down to 23, since that's a little more difficult problem. It says of the following 2,598,960 different 5-card hands. So that's just telling you this is how many 5-card hands you can get. That doesn't necessarily mean anything about the rest of the problem. Okay? So, but we do have a 5-card hand and a deck of 52 playing cards. How many would contain the following? So we have 52 cards. We want to know all black. Well, if we're looking at all black, there are 26 black cards. So, you know, we can eliminate half of the options just by looking at that. So to have probability of all black, or how many black, all we would do is take the combination of 26 cards and choosing 5 of those. And you should get 65,780. The next one we did a frequency distribution, and that's where you just have to give the intervals and then tell how many numbers were in that interval. So if I were doing 6 intervals going from 0 to 49 for the first one, the next would be 50 to 99, 100 to 149, 150 to 199, 200 to 249, and 250 to 299. So I have my 6 intervals going basically by 50s. And then what's my frequency? And that just means how frequent, how many values do I have in each of these ranges. So like for the first one, for 0 to 49, 12 is in that range, 24 is in that range, 49 is in that range, and that's it. So I would put 3. And I would keep going with the rest of the intervals, and I get 3, 5, 5, 5, 4, and 2. Number 25, for that one we just said that because we don't know exactly how many grades there were, even though there was one in each entry from 0 to 99, there may have been multiples of different ones. So we don't necessarily know that the median was 45, so that one was a no. Number 26, it says promoters preparing for an outdoor concert could also set up an alternative indoor site in case of rain. It costs $29,000 to set up outdoors and $25,000 to set up indoors. With clear weather, the expected gate is 128,000. If it rains, the expected gate is 75,000. How should they set up? So what I did is I said, well, I could do just an outdoor space, or it says I could set up an alternative indoor as well. So basically I have to do both, out and in. And then we need to look at, well, given those arenas, did it rain or not rain? I have to do a little bit of math here. We've got, it says it costs $29,000 to set up outdoors. So no matter what, we're going to have an expense of $29,000. And to set up indoors, it's $25,000. So actually, I added them together, the $29,000 plus the $25,000, which is $54,000. So if I set them both up, it's going to cost me $54,000 to do that. With clear weather, the expected gate is 128,000. So that means that if it's clear, so it does not rain, I'm going to make $128,000. Okay, that's at the gate. And then I have to subtract how much it costs for my setup. And then if it rains, it's going to we're going to make $75,000. So plus $75,000. then you have to find each of those differences. So for that one, that's going to be 44,000. 6,000, sorry. If it does not rain, that's going to be 99,000 that we're going to make. If we make both and it rains, that's going to be 19,000. And if we make both and it does not rain, we're going to make 74,000. So then you go through, and for each row, you underline the lowest number. So in the first row, that would be the 46,000. And in the second row, that would be the 19,000. And then you circle the highest amount in each column. Whichever has both an underline and a circle, that's going to be your saddle point, which tells you what to select. So how should we set up? We should set up outdoor. Number 27, a mathematician's course at a certain college suggests that of those students who get a grade of C or better on an exam, 90% get a C or better on exam 2. Of those that get a D or F on exam 1, 70% get a D or F on exam 2. This year, 80% got C or better on exam 1. Determine the proportion of students who are likely to get Ds or Fs on exam 2. So really we're comparing exam 1 to exam 2. And then, so that's my matrix here. And then this is getting a C or better, or a D or F on exam 1, C or better on exam 2, or a D or F on exam 2. And I'm going to write down those values. So it says 90% get a C or better on exam 2. So if I got a C or better on exam 1, I got a C or better on exam 2. So that's 0.9. The rows have to add up to 1. So that means 0.1 then would get a D or F on the second exam. For the next group, it says if I get a D or F on the first one, 70% got a D or F on the second one. So that's 0.7, which means that 0.3 had to have gotten a C or better. And then it says that 80% got a C or better on exam 1. To determine the proportion that got a D or F on exam 2. Well, if 0.8 got a C or better, then 0.2 got a D or F, because it has to, again, add up to 1. And then we're looking at this column. So you take 0.8 times 0.1 plus 0.2 times 0.7, and you should get 0.22. Number 28, how many ways can a committee of 2 be selected from a club with 12 members? We don't care about the order of the selection, so it's a combination. We have 12 members and we want to pick 2. That's all you're going to do. Combination of 12, choose 2, should be 66. Number 29, the table gives the number of unemployed workers in a certain city. In recent years, find the standard deviation for the data and round to the nearest hundreds. This is extremely similar to, let's see if I can find the number, to number 13. The difference being that they give it a table of data instead of just a list, but you're still going to enter it in the list and find standard deviation. 30, a restaurant offered salads with 8 types of dressing. You're only going to get one dressing and one choice of 6 different toppings. How many different salads could you be offered? So we've got dressing, we've got toppings, we've got 8 choices for the dressing, 6 choices for the toppings, so we can have 48 different salads. 31, using the employment information in the table on Alpha Corporation, find the mean for the grouped data. So mean for grouped data kind of looks a little bit different than just finding regular mean. What you're going to do is you're going to extend your chart here a little bit. And the first thing you want to do is find the median of the intervals. Which is called MF. So we go over the intervals. The median for 1 through 5 is 3. 6 through 10 is 8. 11 through 15 is 13. 16 through 20 is 18. 21 through 25 is 23. And 26 through 30 is 28. Then you're going to multiply your frequency times the median. So you're going to multiply these two together. And you should get 15, not 150, 15. 160, 325, 180, 115, and 84. And I'm going to go ahead and total those up because you're going to want to do that. And you get 879. We're also going to want to total our frequency, which is 68. And then to find the mean, you take the sum of XF and divide it by N, which is the number of entries. The sum was 879. You had 68 entries, and you should get 12.93 is the mean. Number 32, Joe and Amy play a game in which they throw either 1 or 2 slips of paper on the table at the same time. If there is a match, Joe wins the amount of dollars equal to the total number of slips of paper on the table. If there's no match, Amy wins the amount of dollars equal to the number of slips of paper on the table. Find optimum strategies for Joe and Amy and the value of the game. And so basically we have Amy and Joe are playing a game, and they each have paper. They either have 1 slip or 2 slips. If they both have 1 slip, then Joe is going to win however many are on the table. Joe's going to win that amount. So there would be 2 pieces of paper on the table. So Amy is going to pay Joe $2. The same thing would happen if it's 2 and 2. This time there are $4 on the table, so Amy would pay Joe $4. If there's some differing amounts, then Amy wins the money. So she's going to win $3 for a 1 and 2 or a 2 and 1. And then I want to figure out, well, what are the optimum strategies? And that's at P1, P2. or Q1, Q2. Now we said for P2 that that's really 1 minus P sub 1, and Q2 is 1 minus Q sub 2. So I'm going to say, well, what happens if Joe picks number 1, or throws one piece of paper? If Joe throws one piece of paper, then for Amy, her optimum strategy, that's going to be negative 2 times P sub 1 plus 3 times 1 minus P sub 1. I'm going to simplify that equation. And then if he throws 2 pieces of paper, Amy's strategy is going to be 3 times P sub 1 plus negative 4 would be minus 4 times 1 minus P sub 1. I'll take each of those, and I'm going to simplify those into little equations. That's going to be E sub 1 then is negative 5 P sub 1 plus 3. And E sub 2 is going to be, let's see, 7 P sub 1 minus 4. I'm going to take each of those equations and I'm going to put them in my graphing calculator. I'm going to let P sub 1 be x and E be y. So their point of intersection is going to tell me what P sub 1 is, so that's the optimum strategy for 1. And then E is actually going to be the value of the game. So that tells me that, for this one at least, P sub 1 is 7/12. You could have given me a decimal. I know if you do it on your calculator, you'll get a decimal. And E sub 1, or E, is negative 1/12. So I could use that. I've got the value of the game. I know the probability for tossing one piece of paper for Amy. And then so to do 2, since it's 1 minus P sub 1, that's going to be 5/12. So those are the optimum strategies for Amy. I would set up exactly the same thing for Q sub 1 and say, okay, well, let's look at the optimum strategies for Joe. If Amy tosses one paper, what are the optimum strategies if she tosses 2 papers? Okay, for number 33, it's actually kind of an easy one. It wants the long-range trend. So the matrix that you're given is like for one trial. For the first week, we want to kind of think of it as an infinite. So we take that matrix, take it to the 99th power, and see what happens to the entries at that point. And it should kind of all level out. And what you'll find is that all of the low entries will be 0.2440. All of the medium entries will be approximately 4211, and all of the high entries will be approximately 0.334